The point of this lesson is logarithmic functions, graphs of the logarithmic functions. First example, find the domain, range, x-intercepts, and vertical asymptote of this logarithmic function. To be able to find the domain of the function, what you need to do is figure out what makes inside the log, whatever, because right now it's the composition function log base 3 is outside, and then inside is another function. We want to figure out the inside function where it is positive, strictly positive, not zero, neither. So that's actually as usual with domain problems. As usual with some other domain problems, this is an inequality. To solve the inequality, I have to find the roots of the equation, which is going to be in here. There's -3 is a root and 5 is a root, and put it on the number line. Okay. Now, what am I trying to do? Making this polynomial, find where that polynomial is positive. To find where the polynomial is positive, I can use checkpoints, test points. So check the test points. Something between -3 and 5 would be 0. If I plug in 0 in here, the value here is going to be negative, so that's not part of the answer that I want. Something, let's say, something bigger than 5 would be, let's say, 10. I can put in 10 and get 100 minus 20 minus 15 is a positive number. Therefore, this part is actually allowed. And I can check again, but I know that this part is going to be allowed too. Why? Because it's a parabola that is looking upward. Therefore, the parabola that looking upward is going to be positive outside the roots, and inside the root is going to be a negative value. So the domain is going to be -infinity and -3, not including union 5 and positive infinity. The next question is where to find the range and an x-intercept. Range of the function for logarithmic function, if you observe one, a parent function, range goes from -infinity to positive infinity. There's no break in it. So the range of this one is going to be -infinity and positive infinity. And the next question is x-intercept. When do we have x-intercept? X-intercept happens when y is equal to 0. That means log of whatever is inside is equal to 0. That means that the inside is supposed to be equal to 1. So to solve for range, for the x-intercept, I have to set the inside equal to 1. And that solves into x squared minus 2x minus 16 equal to 0. By quadratic equation, I get 2 plus minus 4 plus 4 times 16, which is 54 divided by 2, which is 2 plus minus square root of 58 divided by 2. There are 2 x-intercepts. Now, the last question is, where are the vertical asymptotes? Vertical asymptotes. That's when inside function is equal to 0. and that solves to be x equal to -3 and x equal to 5. Now, so this discussion resolves a lot of issues about a domain range X-intercepts of a logarithmic function. How do we graph, one more, oh yeah, how do we graph a logarithmic function? This one is a little bit more complicated. It has two different pieces, so I'd much rather start with this question than that question first. But this one cleared out a lot of domain problems. So with this one, things to notice: logarithmic functions, if you remember from the last video, there are two shapes that I can get with the parent function. One looks like this, the other one looks like this, and then depending on how we use the mirror image, you can get mirror imaged over y-axis, you can get mirror image of that one over the y-axis, or you can get mirror image over the x-axis. But when you get mirror image over the x-axis, you get one of these two options or the other two mirror images. Now, this one has a base 5, and so I have to kind of work with the one that has a base bigger than 1, and that's the shape that we're getting. It seems like the x has moved 3 steps to the right, so I go 3 steps to the right, and that's where I'm expecting the vertical asymptote to happen. Then the next thing to notice is x minus 3 is how do I find the x-intercept? X-intercept in this case is a little bit more complicated and requires a little bit of algebra with logarithm. So x-intercept means y equal to 0, so that means 2 log base 5 of x minus 3 minus 7 is equal to 0. That means that 2 log base 5 of x minus 3 equal to 7, or log base 5 of x minus 3 equal to 7 over 2. And that, by reversing the process, means that x minus 3 is equal to 5 to power 7/2, adding 3 to both sides gets me x is equal to 7/2 plus 3, 5 to power 7/2 plus 3. This is the x-intercept. So again, it's a little bit more complicated, but I don't have to do all of that to get an idea of how this shape works. I can plug in a few points and remember that there was no extra reflection after using that graph, and then therefore the general shape would look like this. This would be my new vertical asymptote, and so I can approximately know that the shape of the graph would look like this. This point, you have to figure out a few points in there, and the shape will be very accurate.